Before developing a data layer to our Spring Boot application, I would like to introduce this database, H2 database engine, that will help us to develop our project in Spring Boot, understand how the data layer works, but it can also be very useful when we are developing tests, prototypes, proof of concepts, and so on. So I'll dedicate a few videos around this database because I think it's useful to understand it, because I'm sure that will be really useful in your projects that you develop in your enterprise or maybe personal projects. So what is this database? This database can be a lot of things, so I will just cover maybe just 3 or 4% of them in these videos, but I invite you to research more about it because it is really useful, and which, by the way, came out of the box with the Spring Boot. So it's a very fast and open source database, JDBC API. So it is compatible with JDBC, meaning that you can use this database the same way that we use an Oracle or MySQL, MariaDB, Postgres, and so on. It can be embedded. Embedded, it's the same as when we are using, for instance, SQLite. You can use H2, but H2 can be really, really powerful. And server modes, you can run this application or this database as you run MySQL or an Oracle. You can create a server, run it on your machine, and connect it using regular connections. Or my preferred one, and this is the reason I use a lot this database, is in-memory database. You can just run the application in your JVM. You start the application there. You just open a connection. You don't have to do nothing. There is no external command. There is no parameter in your Java. You just add the dependency. You open a JDBC connection, and voila, you have a database in memory. And then you can create tables, send data, do SQL, and so on around this database. Now you understand why it's really useful when you are developing an application for showcasing, for proof of concept, for testing, and so on. It can be a browser-based console application. It includes one, but you can use a regular SQL client if you want. And it has a small footprint around just 2.5 megabytes jar file size. It's really small, but really powerful. It has a lot of features. If you click here on the features, you can see in this feature list, this is a lot about this database, and it supports a lot. It's even compatible with Oracle, MySQL, and so on, Postgres including. But let's see, it's just a feature list. So main features, it's a very fast database engine, open source, it's written in Java, which is incredible, supports standard SQL, JDBC API. I read it again, supports the standard SQL. So when you are developing, you can use this database and then later move to a different one. It can be embedded, server mode, clustering support, which is crazy, strong security features, and the Postgres or DBC driver can be used to connect to this database, and supports multi-version concurrency. There are the additional features like this based or in-memory database, tables, read-only database support, temporary tables, two-phase commit, transaction support, isolation. You can see here multiple connections, row-level locking. It seems a regular server database if you look into the features. Cost-based optimizer, scrollable and updatable result set support, and encrypted database. For a free 2.5 megabytes, it's just crazy. And you can see here the support for SQL. It has some advanced features that I will show you in a further video about CSV, custom functions. You can even execute Java methods of your code inside the database, which is crazy. Of course, when it's inside your application embedded or in memory, of course, outside it's not possible. Supports multiple schemas, information schema, refreshing integrities. There are no specific limitation on this database when you compare with regular SQL database. We are talking, of course, talking about the relational database. Inner and outer join, subquerying, read-only views, inline views, triggers, Java functions, stored procedures. Okay, XML inbuilt functions, blobs for images, arrays. Some databases don't support arrays. Sequence, identity columns, generated columns, order by, group by, having, union, you name it. Okay, Windows functions, collation support, which is quite useful. Support for users and roles, and compatibility modes for IBM DB2, Apache Derby. This is it's a similar database like this one, MySQL Server, MySQL, Oracle, and Postgres. meaning that when you start this database, even in memory, you can say, okay, it should be compatible with Oracle. Of course, it will not be fully compatible with advanced things or particular things of Oracle, but standard things of Oracle will be supported. So there are security features. You can look into this website, and I invite you to do so. Other features and tools, CSV, I like this one, and I will show you in a specific video about to support CSV files when you are inserting and selecting from a table, and so on. But in our case, I will just target the in-memory aspect of this database. So let's see an example of this database in our application. So I created a project. It's not our Spring Boot project. It's just a parallel project to explain how this database works. In a further video, I will create H2 in Spring Boot, and Spring Boot is already configured to use this database. For instance, you can specify a set of files, SQL files, and when your application starts, you can ask to Spring to connect to this database, put it in memory, and automatically create, for instance, tables and execute specific DDL SQL, meaning to create tables and so on. And then you can specify other files to insert, update rows, or you can initialize a database out of the box. In memory in a Spring application, and it's everything using properties, which is great. So how to use this database? And now you see how simple is this. You just added this dependency. That's it. After this, you have access to JDBC, and you use it as a regular database. There is no installation here. There is no specific parameters on the main. There is nothing. You just need to add this dependency. Now, let's see a main application that I created, a small one. You can follow this application. You can create it yourself, and then I invite you to do so you can practice and understand how this database works. So I have a main, and the first thing that I'm doing is just get a connection, okay, like this. And I want to create a database in memory, name it UsersDB. It's optional. If you don't create, if you don't give a name to the database, what will happen, it will be a private database, meaning that any connection that you open to H2 will always target that database. Sometimes it's the common case. But if you want to give it a name, or maybe you want to create multiple databases, you should give it a name. Of course, this is our class H2, which is this one. It's not how you create the database, but let's see how can we create a database. So I have this class here, which is H2 database, and I created a method called getConnection. And we can specify the name of the database for this connection. And when we open a connection with a name, it will create automatically database. You don't have to execute a create database on this. So this is just JDBC stuff. It's not H2 stuff. So we have driver manager, get connection. That's how you get a connection using JDBC, standard for Java. And now it's just the JDBC standard scheme. So you write JDBC. Then H2, meaning it's your database. Now inside the H2, I want in memory. And now what I'm doing is just the database that I specified here on the parameter with here. And I'm adding, I don't know why I put a double one, a semicolon here. So you can see that db close delay -1. This is optional for our examples. If you remove this, it will work anyway. But when we add this, and I put it here, a comment says, keeps the database in memory as long as the JVM is running. Because if you close the connections, the database will go away. So if you want to make sure that your database is always running, even if a connection is closed, you just put here db close -1. You can put a delay. Imagine that you put something like 5 seconds or 10 seconds. You can always say something like, okay, I open the connection, I close it, but if in the next 10 seconds is still, if I open a connection, for instance, the database is still there. So it's a kind of a in-memory cache for a while, saying, okay, maybe you close the connection, but you want to open another one in the next second. So I will make sure that the database will remain in memory. But if you add this, it will be database will be in memory until you really close your application. Meaning when you exit, be careful. If it's a server and you put this, the server runs inside the JVM. So the total time of the execution for the server, the database will always be there, even if you close all the connections. Okay, so be careful when you use it. In a main application or regular application, it's okay. In a server, make sure that you know what you're doing, because Maybe when you are having a server or you're running tests, you want to use multiple scenarios, you want to create multiple databases and close other ones. In that case, just remove this DB close delay here and just use it as standard as is. And when you have other database, the other one will be, let's say, recycled and remove it from memory. So this is how we get a connection. So driver connection, get connection, and it will create automatic database. By default, the user is SCA and the password, it's empty. Unless you change it, but usually it's in memory. There is no reason to, let's say, protect too much this database, right? So this gets a connection, like here. Okay, so here you have a connection, and now I'm creating tables on this connection. And the way to make sure that it's on that connection database is using the same connection. And here, again, we call the create table users and just a regular create table SQL. Create table users, ID. Here, auto increment, saying, okay, I don't want to specify the ID. So every time I do an insert, you will provide an ID automatically, like 1, 2, 3, and then a username and password and an email. It's not important, the columns here, we are not developing a user's administration application, but to be as real as possible in the context of for educational purpose. So we have the statement, again, it is just common JDBC standard, and then execute the update, and this table will be created in memory. Okay, so here we create the database by opening the connection. Here we create the table users, and now I created this class, users DAO. It's a pattern saying data access object, which has a few statements to insert users that you can see here. So I'm creating a loop to execute 10 times, and it will instantiate a user. Of course, I don't provide the ID because the ID will be generated by database, but I'm providing a username, a password, and an email, and I'm just using this variable to make sure that users are different. Okay, so users DAO here again. Add user, so I receive a connection and I create the DAO. It's a good practice to inject the connection on the DAO. Now when I call the header, I just prepare the statement, again, regular JDBC stuff. Insert into users, we don't specify the ID, just the column names and their values, and we expect to create a user when we execute this add here. Okay, just prepare a statement, set string, execute update, and that's it. So here, we are doing this 10 times, and then later we use the same DAO here to get users. It's another method that will select all the users, and then for each one, we just do a toString. And if you go to the user, the class user, if you want to see it, just a regular class with ID, username, password, and email, and with a toString here. Okay. Usually this toString you can generate it if you are using IntelliJ. You can ask him to generate this toString, but you can do it yourself. If you override it, of course, you should do this when you do the system out of your object. In this case, you will be a user. It will execute toString, and you can see the output of the user. So let's see the get users here on users DAO. It's just a regular statement, create statement, select ID, username, password, email from users here. Then we instantiate an array list, so we can add users to this list. So while there are users, the common pattern when we are using a result set, JDBC, so we add to these users, again, a new user, and we get the ID, we get the username, we get the password, and of course, we get the column email. Okay, and then return user. This is just a common JDBC. During my Spring videos, I will provide other ways to connect to database like Hibernate, JDBC client, JDBC template. There are different mechanisms that you can use. I will show you all of them. But for this example, to show how compatible and standard this database is, and the great thing that it works in memory, it's a really useful use case. So I'm using the standard stuff because that's where everything starts. So let's execute this. Hope it works. Take a while to initialize the application. It's the first time that I'm executing, so it should work now. And you can see here the users that were collected from the database. ID 1, 2, 3, the number was auto-generated with these users. It took a while because it was the application executing. If I execute again, it should be faster now. Okay, because there is no need for compilation. You can see database is really, really fast. So here's the data. If you try it, it will, you can see how fast this database. So in this lesson, that's what I wanted to show you about H2. This is an introduction. With this information, you can already create, you can already implement a database application, because we now understand how to create a database using H2, how to execute DDLs. So it's, again, just to take the connection and execute common SQL to create tables or whatever you need. You can add foreign keys. I didn't put it here because this is not about SQL, it's about the database. And then we can make queries, so inserts, deselects, but you can as update, deletes, so you can implement a full application using JDBC, even in Spring if you want, using this H2 database. I will develop maybe 2 or 3 more videos about H2, because it provides advanced features that can really be useful, and I think it's great for you to understand how to work this database. It will be a great tool for you to have on your toolbox. Okay, so I hope this was useful for you. Please comment, subscribe, share the videos as much as you want. If you want to learn something, you have a good idea, just drop it in the comments. I will take into consideration, put in my queue for future videos. As you know, I'm developing now at least a Spring Boot series and a reflection, but sometimes I just stop and like to do other stuff for a while. So don't be afraid to just comment and add some propositions there. Okay, so I hope to see you in my next video. Thank you for watching.